Hello and welcome to Grade 3, Unit 13 on Perimeter. My name is Daryl Frost.
I'm Barbara Knox. Welcome.
In just a moment, you're going to pause the video and complete a task. The task will be on the next slide. You can either complete it independently or with your grade level team or one other person. We're going to ask you to grab some AngLegs, which came with the STEM Scopes kits, or you may have them already. We want you to use AngLegs to create a concrete model of the problem, and then solve the problem and write an equation or equations that represent the problem. And as you are working through the task, there'll be 3 questions at the bottom of the slide. I'd like for you to reflect on those and anticipate some exemplar answers you would expect of your third graders.
We'll see you back in a few minutes.
Happy problem solving. Before we actually take a look at that problem you just solved, let's take a moment to look at the progression within BEST related to perimeter. Notice that in the early grades, kindergarten, first grade, we're really focusing on that measurement strand, talking about attributes of shapes. We began looking at perimeter with counting square units in second grade. In third grade, we continue our focus on perimeter, but we're working on helping students develop formulas for both actually perimeter and area.
So this unit is focusing more on perimeter.
Correct? Yes, we're strictly focusing on perimeter within this unit, and we're highlighting within this particular Math Dive-In 5 the
composite shapes.
Which is, we now say composite instead of what?
Instead of rectilinear. So within BEST standards, the vocabulary is shifting a little bit to composite figures instead of rectilinear.
There we go. All right. Take just a moment to read through all these vocabulary words. When we say academic language, this is the academic language that both teachers and students should be using through questions and through conversations and discourse that's happening about perimeter within this scope. So here we have the problem, and notice, Barbara, we see an equation there, right?
We do.
And so we know that 22 yards represents what?
The perimeter.
The perimeter. And it's important to note that one of the clarifications within that GR 3.4 and 3.3 actually is to write the unit of measure in word form. So
well, it's important to include units, right? We don't know if those are yards or feet or inches or miles unless we record that unit.
So every teacher now that has completed this has actually created a model with their AngLegs, right? So should have. So let's make sure, and we want to pay close attention to the colors in the context of matching the links, the linear links here.
Correct.
Since this is a linear measurement. So we think about, okay, well, I'm using the purple to represent 3 yards. So, and then I use the blue for 5 yards. There's my 6 yards represented in red. Yellow's 2 yards. And then what are these other?
It's orange is 2 yards.
Orange is 2 yards. What about these other 2,
well, they have
3?
To be purple also because they're also 3 yards.
So that is what each teacher that's participating in this task should have created a model of that.
Correct, because if we connect 2 purple together, it's going to be the same length, approximately the same length as the one red.
Exactly.
And if we connect a purple and orange together, like the 2 side lengths, the 2 yards and the 3 yards together, it should equal the 5 yards on the opposite side, which is blue. So a purple and orange together should be approximately the same length as a blue.
And then a student understanding that perimeter being is 1 dimension, right, versus area is 2 dimensions. What could they do with those AngLegs?
With the AngLegs, I can unconnect the angle eggs at one point, at one vertex, and then stretch those angle eggs out into a straight line to show that the perimeter is that length unit.
And every teacher probably just did that. They just
Yes.
completely took them
Hopefully.
apart, and then they could see, oh, well, that really is a linear measurement. It's
Yes.
one direction.
Yes.
All right. And so thinking about strategies might a student use? Well, the angle eggs here, right?
Correct.
They could also do what? Once they've created this concrete model, what else could they do?
They could do a representational model on paper.
Sure, and the diagram was given to them as a
Correct.
representation,
Correct.
but I would certainly want them also to be drawing that themselves to get to and make those connections between the concrete and the representation, and then connecting it to that equation you see on the
And
slide.
thinking about your last question, we know that we're focusing on area with this problem, but if this problem was focused, we're focused on perimeter, but if we were focused on area, we would have had to have decomposed that into rectangles.
Yes.
In order to find the area, where with perimeter, we don't need to decompose it.
Are there any challenges or misconceptions that you see that, given the context here, that a student might have?
Sometimes side length might not be given. So let's say that the orange piece didn't have a measurement beside it, the 2 yards.
I'm going to stop you right there. I'm so glad you said that, because within the clarifications, there's no division involved with the or no subtraction or anything involved.
They're going to be given.
They're going to be given
units?
all the side lengths.
That's new from last year.
It is. That's a change. But also thinking about the context here, you know, why is this perimeter versus area? Because they've already taught, you know, Unit 12 is on area.
Right.
So do they understand, oh, well, it's about fencing, so it's about going around a shape or a figure.
And students do confuse area and perimeter quite often. So they
Yes.
need to know that that area is covering up space.
Right.
And that perimeter is a linear measurement.
There you go. All right. So here are three potential misconceptions and obstacles that could occur with focusing on perimeter. Notice the second bullet there, it's got that arrow going to it. There's a lot of text there, but the whole idea with perimeter, just like with every math idea, they need to go through that CRA process, like what we have discussed today, where you built with angle legs, that concrete model of that. You had a representation in the problem itself. There was a diagram, and then taking it to that equation. So just that's important to remember.
We also want to caution you about using color tiles with perimeter. A lot of times students will confuse area and perimeter when you're using color tiles. For example, I see 3 color tiles, 2 yellow and a red color tile around the perimeter of this composite shape, but that red color tile might be counted as 1 unit instead of the 2 perimeter units that it is accounting for. So be really cautious about using color tiles because they take up space instead of covering just the line segments that those measurements are intended for.
That's an excellent point. Yes, very good. So here is a recap on the CRA process. You built with angle legs a concrete model of that composite figure. Then you were given that representational representation of it, I guess you'd say, in the problem itself, but I'd still want students to be drawing that. And then, of course, that takes it to the equation where the perimeter of the composite figure was 22 yards. So that CRA process is still just as important in making connections between each of these models. Well, we hope this Unit 13 Math Dive in 5 for Grade 3 on perimeter has been helpful to you, and we'll see you next time.
Thanks for joining us.